Hello friends, today we will see one of the important aspects of the effects of earthquake, namely tsunami. You may recall the damage caused by the tsunami which occurred due to the earthquake on December 26, 2004. More than 2,20,000 deaths were reported, and we have lost millions of rupees due to the tsunami caused by that earthquake. In this episode and the following episodes, we will see some of the terms related to tsunami. Then we will see how they are caused, how they propagate, and how the damage is done at the coastal areas. We will also see how to mitigate the effects, and since warning systems can be deployed for tsunamis, we will see some of the aspects of the warning systems also. Tsunami is basically a Japanese word. It's made of two words, Tsu and Nami. Tsu means harbor and Nami means waves. One more term is coined, which is called as tsunami earthquakes. A tsunami earthquake is defined as an earthquake that excites much larger tsunami than expected from its seismic waves. Basically, tsunamis are oceanic gravity waves generated by submarine geological processes. The earthquakes, the volcanic eruptions, or landslides beneath the oceans, they disturb the water and then in turn generate the tsunamis which reach the coastal areas and cause damage. Tsunamis are usually not traceable when they are in the mid-ocean, but as they reach the coast, they become large and then cause the damage. They are sometimes called as seismic sea waves or erroneously the tidal waves. Tsunamis have many aspects which are studied by various experts. The generation of tsunami is studied by the seismologist. It is a geological process. Then the generation and propagation is the field of hydrodynamics. Then at the coast, the coastal engineers and the administrators, they see the damage and study for its mitigation. Now let us see some of the important tsunamis which have occurred. The first tsunami which I would like to take up as an example was the one which was caused in Japan in 1993. This particular tsunami was studied by many research workers. The other tsunami is that which was caused by 1960 Chilean earthquake. And you may recall that this was one of the biggest earthquake in the history of the earthquakes. This has caused the tsunami which reached the coast as far as 24 hours away from the cause of the earthquake. One of the typical tsunamis was caused by Aleutian earthquake in 1946, which was having MS, the magnitude, surface wave magnitude, as 7.4. Tsunamis are mostly caused in Pacific Ocean, but we can see the history. Tsunamis have been causing damages on Indian coast and on Asian countries' coasts, and they were generated in the Indian Ocean. If we see the history, then we can see the 10 deadliest tsunamis caused in Indian Ocean. The earliest tsunami was caused in 1762, 2nd April, in which 500 deaths were reported in Bay of Bengal. The following table gives the 10 deadliest tsunamis arranged as per the reported deaths. The plus sign on the numbers shows that the deaths were also due to the earthquake damage. The impact of tsunami can be traced back to 1418 BC in the history, where the Minoan civilization was washed out by that tsunami. Japanese documents shows the history back to 684 AD, while in North and South American records they date back to 1788. This table shows some of the documents available on the reported deaths for the historical tsunamis. It starts from 13th century onward. From the socio-economic point of view, the losses to the society are in terms of losses of life, loss of property, and the property loss in terms of imports, exports, manufacturing, and tourism industries. We have witnessed in the last 20 years a lot of development along the coastal regions in the developed or developing countries. This has resulted in the explosion of population and making it necessary to save them from the damages caused by tsunamis. The risks posed by tsunamis are flooding, contamination of drinking water, fires from ruptured tanks or gas lines, loss of vital community infrastructure. These things, they necessitate that we should study the tsunamis and then mitigate the effects. Now we'll see some of the terms related to tsunamis, how they are measured at the coastal region, and how to define those terms. Basically, tsunami is a series of ocean waves having very long wavelengths and long periods, which are caused in water bodies due to displacement of water. It may be due to earthquakes, landslides, or volcanic eruptions. Most of the tsunamis are associated with the earthquakes. So it means the tsunamis are caused by any disturbance beneath the water column which disturbs the equilibrium. As a result, the waves are formed due to the displaced water and work under gravity to regain the equilibrium. Let us see how the tsunamis are generated. We can divide the generation in 4 parts: the initiation, split, amplification, and run-up. The initiation of the tsunami is due to the earthquakes. Not all earthquakes they generate tsunamis. It is only the fault plane solution which defines which of the earthquakes will generate tsunamis. The rivers dip slip faults. They generate the tsunami because they can displace the water, and in turn that displaced water will move in form of tsunami waves towards the coast. For example, the Sumatra earthquake. It was reverse dip slip earthquake which caused the tsunami. Within few minutes of the occurrence of earthquake, the tsunami is generated. The potential energy is changed into kinetic energy, and the waves, they start moving in the horizontal direction. The tsunami at this point splits into two. One that is going towards the coastal regions, and the other one which is going towards the deep sea. Now, since the velocity of the tsunami wave depends on the water column, the waves which move towards the sea are of much higher speed than those which moves towards the coastal regions. The amplitude starts increasing when the waves, they move towards the coastal region because of two reasons. One is the depth of the water column reduces, so the energy has to be compressed in the vertical direction, which increase the height of the tsunami. The other is that the wavelengths, they start decreasing. The figure gives some idea about the speeds, the depths and the wavelengths found in the tsunamis. You may see that at depths of around 7 kilometers, the speed of tsunami is about 940 km per hour, having the wavelength of 282 kilometers. The same tsunami which reaches the coastal region, these parameters changes to the depth is around 10 meters, the speed becomes 35 km per hour, and the wavelength, they reduces to about 10 kilometers. So these are the reasons why the amplitude of the waves, it increases drastically, damaging the coastal areas. It feels like a wall of water approaching the coast, and the reason you have seen. When the tsunami reaches the coast, it goes inside the coastal regions. We define the term like run-up and inundation as in this figure. The run-up is the height up to which the tsunami has reached. So it is the vertical direction in which the run-up is measured. The inundation is measured in horizontal direction from the mean sea level. Now, depending on these, the distance from the source, the height which we call as run-up, and the horizontal direction, the tsunami magnitude is defined. Let us see how to find the tsunami magnitude. The traditional magnitude used for the tsunamis is by Imamura Ida. Imamura Ida gave the descriptive magnitude for tsunamis, which can be given by this formula: m equal to log h to the base 2. Here the height h is the maximum run-up height in meters. Hattori in 1979 extended this magnitude to far-field tsunamis. The formula given by Hattori is m equal to 3 plus log of the terms h and r divided by log of root 5. Here h is in meters and r is in kilometers. Similar to the earthquakes, the intensity of the tsunami is also defined. Soloviev in 1970 found that the Imamura-Ida magnitude scale was basically the intensity of the tsunami, and he defined the intensity as I equal to log of under root 2 h. Similar to the earthquake intensity scale, a tsunami intensity scale was proposed by Papadopoulos and Imamura in 2001. This was similar scale on 12-point scale. Three main features are seen to assign the intensity for a point on coastal region in case of tsunami. These are tsunami's effects on humans, effects on objects including boats, and damage to buildings. You may recall that we have also seen similar ABC type of observations in case of earthquake intensity scales. Let us see how this scale looks like. You can see intensity 4 is felt by all on board small vessels and by few people on board large vessels. It is observed by most of the people on the coast. Regarding the vessels on shore, few small vessels, they move slightly and no damage is there on the built environment. Similarly, the other intensities 6, 7, 8, 9 are given. Let us see the intensity 10, which is very destructive, and run up to 8 meters are observed on the coastal areas. General panic, and most of the people are washed away in this intensity. Most large vessels are moved violently on shore. Many are destroyed or collide with buildings. Small boulders from the sea bottom are moved inland. Cars, they are overturned and drifted. Oil spills. Fires, they start. And there is extensive ground subsidence. Now you remember the damages in terms of grades. Damage of grade G4 in many masonry buildings. Few reinforced concrete buildings suffer from damage grade G3. Artificial embankments, they collapse, and the port breakwaters are damaged. Let us see, for example, the damage caused by Sumatra earthquake tsunami in Nagapattinam. You can see all the material is washed away. These figures, they show how much damage was caused and the run-up and inundation in Nagapattinam. In this episode, we have learned about some of the terms used in tsunamis. We have seen the socioeconomic aspect of the tsunamis. We have defined some of the terms and then some of the damages. The historical tsunamis were also discussed in this. In the next episode, we will see some of the damages caused by the Sumatra earthquake tsunami and the warning system which is used to warn the public at the coastal region from the tsunamis.